All right, it is 10 a.m. East African time for those on Zoom. Good morning from Arusha. Thank you all for joining us again. We will start with a 90-minute, very exciting session. Mojaloop releases in core, led by Sam and a whole host of people, both here with us in person and virtually on Zoom. So I will pass it straight to Sam.
Thank you, Sammuel. Good morning, everyone. It's good to be here in person and kick off sessions on day 3. Presenting with me today, we have Miguel Libaros, Vijay Gutti, David Fry, and Tom Daly in that order. My name is Sammuel Kummary, for those of you who don't know me, and I'm part of the Mojaloop core team. And I'm honored to be representing the Mojaloop community as a contributor in the Mojaloop Community Council as well. All right. This is not the entire list, but we still wanted to acknowledge the contributors in the core team. So we have several work streams ongoing. As we've seen yesterday, we have vNext development. So we have several ongoing work streams. We have the core maintenance and releases team. We have vNext. We have code quality and security work stream. We have people working on V14 charts. Business operations team, and a lot of other individual contributors who are also contributing fixes and features upstream. So thank you all for this. So we were able to get these from your commits and other contributions on GitHub. All right, today we'll cover where we are with Mojaloop core services, a brief overview and like a very quick snapshot of the background. And then we'll go into a little bit of detail on the Mojaloop release V1310, which was the main release made during the last PI. We'll hear from Miguel on that, and then Vijay will cover the testing toolkit update, bug fixes, enhancements, and where we are with it on that. Then we'll have David Fry talking about infrastructure as code updates. And we'll have Tom Daly talking about Mojaloop V14, charts improvements, and enhancements done on that front. So as part of the overview, I don't know if this is visible, but this should be uploaded in GitHub, so you can take a look. We are currently in phase 6 of Mojaloop, just concluding PI 17 and entering PI program increment 18. I've listed some of the active work streams over there, but it's not exhaustive. The component diagram here as well, this should be there for those attending in person. We have this on the placemats. The only new addition is that we have the third-party services, which are now not proof of concept, but as we've seen yesterday, the services have been productionized, and these are part of standard Mojaloop releases now. Here is an overview of how the cycle works, a bug process. When a bug is raised, what happens? It goes into triage, prioritization, fixing, validation, testing, and various things. So coming to what we did in PI 18 and compared to the goals, what we had at the beginning of PI 17 as well. So we wanted to do a Mojaloop release 13.10. And as we have the green tick mark there, we were able to accomplish that. And there are several items. Obviously, one of the priorities or goals of the core team is to assimilate or absorb changes from several other feature work streams as well. Like, for example, the business operations framework work stream, third-party work stream, finance portal, infrastructure as code, and the QA and validation teams as well. Support them where needed, documentation and sandbox and things like that. And then also maintain the golden path test for Mojaloop. So we were able to do this. Good work went into maintaining the tests. A lot of new tests were added, some tests fixed. We have an entire new set, 2 new collections for bulk functionality and then third-party functionality, which are now part of the golden path set of tests. So this was done, but we were not able to make the Mojaloop V14 release. This is still in progress. As we will see in the coming presentations sections, there's more work to be done there, but that is still on our goals section. With that, I will pass on to Miguel for an update on Mojaloop releases. So give me a moment to...
Hey everyone, sorry I couldn't be there in person. I'm Miguel Gabarras from Motorsbox, a Mojaloop principal architect working on the open source funded development project, part of the team designing and engineering core Mojaloop services and a member of the Mojaloop Design Authority. I'll be taking you through the PI 17 updates, specifically the 2 releases that were made in this PI. Starting off with 13.1.1, which is a patch release, and this was purely introduced to fix an issue which allowed one to disable finance portal deployments via this flag that you see on screen. So previously before this, when you would set this in the values YAML, it would still deploy the finance portal regardless. So at least that's been fixed, very minor release, nothing serious about it. The second is 13.1.0, and this is the main release for the PI. And here we have a couple of the main changes that were introduced with this release. The first being support for patch notification failure scenarios. As a result of this, paid DFSPs will now be notified of any process validations once the put transfer callback has been accepted by the switch, with an invalid fulfillment being such a use case as an example. In addition, we've also introduced the third-party API Helm charts and supporting services. So this includes the third-party API service itself, the central authentication service, and the consent oracle that one is able to register against the ALS. In addition, we've also introduced functional tests for both third-party and bulk FSP IOP services using the Mojaloop testing toolkit. And you're able to use these via the Helm test command. The next is about our continuous growth settlement tests. These have now been integrated or merged into the Golden Path test collections. And this means that now we have a tight validation between settlements, and they're closely integrated into our Golden Path as a result of this. The last main point here is also there's a slew of bug fixes that I will go through in more detail once we review the release notes themselves. The third point here is just pretty much that the core team has been spending a lot of effort and time supporting ongoing adopters and implementers. And such an example of this is actually the patch notifications that I discussed above, as well as the bug fixes that we'll go through in more detail. The fourth point is about the reference architecture support stream. This is an ongoing thing, which is about updating documentation as well as feeding into the VNext workstream. And that VNext workstream, you'll see more info about when Pedro presents it later on. The last point is about supporting the progress in Mojaloop v14. Tom Daly will be taking you through that in more detail after this presentation. Let's go to the release notes. So following the link, we see the usual information that we would expect to see here. We have the new features. A lot of them I've already covered, from pretty much including or merging the CGS test cases, as well as there is also the account lookup sub-ID error callback endpoint, which was not implemented. This has also been resolved. The actual implementation was there, but it was not linked up to the actual API itself. So that's now being sorted and resolved. We also have the third party, which we already discussed. We also have the patch notifications, which was also already discussed. And we also have some improvements to the testing toolkit about moving the object units to the system configs, and that will be talked about a bit later, as well as adding additional label information or descriptions on the test cases themselves, as well as adding support for third-party SDK outbound API. And we also have ability to group reports and definitions within the reports themselves. We've also added resource configuration for the SDK scheme adapters, so now we're able to correctly set the actual API versions. And with regard to this, I'm talking about the Mojaloop specification versions themselves. So for example, we have 2 versions at the moment, version 1.0 and version 1.1. And the last point here is very much related to that as well. We now have a better way to configure the support for which versions that you want to use going forward. I'll go through that a little bit more in detail further down. We have, once again, a slew of bug fixes and everything from making sure that when you run the migrations database scripts, the quoting table and a couple other tables are correctly set to UF8. And this is really needed to support a wide character set, specifically with regard to DFSV names, etc. We also have a bug fix for the settlement windows when using v1.1 with regard to patch notifications. When you receive the put callback, etc., the transfers not being correctly assigned to actual settlement windows, and that's also being resolved. And we also have some issues with the destination headers are not being set correctly when actually processing put callbacks on v1.1. We also have a bunch of bugs that were fixed. Actually, this was fixed by the protocol versions that we introduced when we were doing validations on incoming requests based on the FSP IP versions on the headers. They were basically not being validated correctly, and this has subsequently been fixed. We also fixed an issue with the SDK scheme adapter not returning party sub IDs. This has also been corrected. There were also a bunch of bug fixes to the bulk API adapter. So we found there were some issues with the extension lists. The bulk API adapter would actually fail if no extension list was provided. We've subsequently fixed this and also updated the test cases to ensure that we are also making sure that extension lists are not included, everything works. We also have another bug also, once again, with FSP IP destination headers. We were just incorrectly mapping the FSP ID and making sure that we validate that correctly. And we also had a strange issue where quotes would actually fail when the transaction ID did not equal the transaction request ID. So if you did include a transaction request ID, it would have to be equal to the transaction ID to successfully process a quote. And that's also been fixed, and tests have been added to also make sure that is the case. Some minor fixes also with Oracle Pathfinder, just a startup and edit issue. I was just maintaining it and making sure that we're using more recent doc images, etc. A couple of testing toolkit fixes from TLS connectivity when running in hosted mode to also the callback maps for FXRPs, as well as some other issues with soft buttons, etc. And as well as fixing some overrides when setting callback rules in the simulator itself. Moving on, we have the application versions, and below that we have their subsequent release notes. And above that, on the application versions, you can actually see the versions that we upgraded to. So for example, MI adapter from 11.1.6 to 13, it's quite a big update. And once again, you can view those individual release notes in section 5. Let's move on to the breaking changes. There are no real breaking changes with this release, but I believe these are just more, these are big enough to really include here just so people are aware of them. So testing toolkit, previously mentioned, we've moved the actual TLS configuration from the user config to the system config. So be aware of that. If you're going to deploy or update to the version, you have any custom configurations like that, you also need to make that change in your configurations. Another is about Helm test job names. So if you have specific configurations for your Helm tests, be aware that the names have been changed, and this is a result of introducing more tests for Helm. And this is for the bulk API adapter, for the third party, etc. So be aware that now we have these new names. Upgrade notes, also Mojaloop simulator. If you have any rules, be aware that the rules path has also changed. You now require a $, prefix. Be aware of that. This has also been documented in this issue. Feel free to go there and view more information about it. The second point here is about the new environmental variables that have been added to the testing toolkit default values. And this is a result of introducing the continuous growth settlement into the golden path, as well as supporting the third party in the bulk API tests, etc. So these are all new environmental variables that have been introduced. So be aware of that. Go check what the default values are and make sure that you align to them. This is assuming that you've overridden the default configurations for the testing toolkit as well. The third point here is about supporting the content type and accept headers with regard to the FSP, IOP validations, etc. And this is about the protocol versions that were mentioned above. So now these services here, ML API adapter, account lookup, quoting, bulk, and transaction request services now have a new configuration called protocol_versions. In here, you'll be able to configure and set how you want these APIs to validate and produce messages based on the FSP IP standard. For example, here we have the content type headers that we would want to do. We have a default configuration here, and this is used for any messages that are generated by the switch itself. And below that, we have a validation list. And this, of course, is to validate any messages that are received by the service. So for example, here we have 1.0 and 1.1. So if a message is received with the FSP IP header content type with one of those versions, we will accept them. If we receive like 2 or something like that, we wouldn't accept that. So you might want to configure your services to only support 1.1, for example, so you would remove 1.0 from this list. Similarly, for accept, we have the same structure. We have the default. This is for now producing our accept headers out of any messages that the switch will actually generate. And this is now the validation list for any messages that are received by the switch to validate, or the service rather. We also have the ability to enable both bulk and third-party components. Please refer to the deployment section in the Helm README for more information about that. Be aware that the third party has some prerequisites that you need to deploy, specifically with the backends. With regard to the version 14 of Helm, we are specifically removing the actual backends themselves from the actual Helm deployment, and as such, the third-party components are aligned to that. So you will need to take an extra step to deploy those backend components, which is a database and a Redis cache. Testing notes, the usual testing notes, we really recommend using the testing toolkit to do this. This is really the test suite of choice that we use, and it's also where the test cases or the test collections are the most up-to-date and are really the ones that you want to use. In this release, we've tested this against Kubernetes 1.20. I've personally also tested this against 1.21, so it should work no problem, as well as the Ingress and the testing toolkit versions that we used for this. Third-party testing toolkit collections are not repeatable. Be aware of that. There is an issue, a known issue, which is also logged in section 10 below, known issues. So if you have problems running the testing toolkit collections a second time, be aware of this. It is possible to go clean up the data manually. There's more information in here if you want to know how to do that. And this is a result of the authentication devices that are used in the third party, etc. So a lot of those things, unfortunately, at the moment are hard-coded, and as such, you need to manually go and do the cleanup as a result of that. It's worth mentioning that there, hopefully this will be fixed in the ongoing PISB stream work going forward, as well as the introduction of the new changes that are being introduced in the third party. I'm hoping that we will have repeatable tests as a result of that. As previously mentioned, we both have bulk API help tests, referred to the test and deployment section here, and also third party. There is a section on how to test those, etc. Known issues, there is only one new issue that has come as a result of this release, and that is the third party testing toolkit collection, which is not repeatedly mentioned, but otherwise all the other issues are known. Be aware that currently we still do not support Mojaloop, Kubernetes version 1.22. Our target is still to have that, one of the goals in version 14 is to resolve that. I believe Tom will speak a bit more about that later on, and he also has an interim solution that if you're really interested, you could use for that. Thanks to everyone who contributed from the Bill Melinda Gates Foundation, Crosslake, Motorspark, Cybrin. Thanks so much. The individuals who really made this possible: Sam, Vijay, Shashi, Kevin, Lewis, Donald. Thanks so much, guys. It really would not be possible without your effort. I'm going to quickly take you guys through a deployment of Mojaloop version 13.1.1, just to show you what the Helm tests look like, and also the Slack notifications that we see on the announcement channel in Mojaloop. So I'm just going to run the Helm search repo Mojaloop/Mojaloop. I've also added this extra parameter max column with 600. And this is just to show you the Helm chart's name, the repository here, / the name of the chart. And this is the version 13.1.1. And this is the app version column, which I want to show you has all the actual individual Mojaloop services as well as their versions that are displayed here, and this matches what you saw on the release notes. I'm now going to deploy this using a custom configuration to our Mojo1 environment in our namespace Mojo1, called Mojo1, repository Mojaloop / Mojaloop, which is the Helm chart. Once again, 13.1.1 is the version, and here is my customized values file for that environment. And that, of course, includes configurations to enable bulk API adapter, third-party API, as well as the tests for those two components, as well as custom configuration for Slack announcements. While this is deploying on the left, I'm going to open K9's on the right, which is just a terminal tool for Kubernetes, so we can see what's happening. So here we just have the backend dependencies for the third-party API. So we have the auth service Redis, cache, auth service database, as well as the consent Oracle database running. So these were installed preliminarily before I did this. We're going to now watch this deploy, and I'll speed things up. Now we can see the deployment was completed, the templates were processed, and the Kubernetes descriptors were sent to the Kubernetes API. And on the right, we can see those services coming up. The red services indicate they have not successfully started, and this light blue indicates that it was successfully started. So we'll see these red services crashing, restarting, etc. And this is because their backend dependencies are not up and running. For example, the database is not up and running, etc. And of course, Kubernetes is a self-healing runtime environment, so these APIs will continuously report that they failed until those prerequisites are met. And you'll see these APIs or these components or services eventually will start up successfully after some time. So all the services are now reporting healthy. That took just over 4 minutes. Normally, depending on your resources, a deployment can take anything between 4 to 8 minutes. On the left, once the Helm install is completed, you can see these instructions on information on how you can find status of the release, the deployment, as well as how you can run your tests, and also run your tests and print the logs to the console, as well as fetching the actual individual logs for each of the tests themselves. So I'm now going to run the Helm test command with the log parameter. And on the right, we will start seeing the test jobs appear. You can see the provision script that's executed, the TTK test setup. And once this is completed, we will see the GP tests, the golden path tests, the bulk tests, the third-party tests, etc., all execute in order. That is completed. So we should now see there we go, golden path. So the setup, the provisioning, that will include everything from setting up the DFSB accounts, registering the DFSBs, to setting up the settlement models, to registering the oracles for the ALS. That's all done in the setup. There should also be another setup script specifically for the third party, which we will see a bit later on after the bulk successfully completes. You can also monitor the logs of the tests, and here you can see so far 2,400 tests have passed, 0 have failed, and you can see the summary that's printed here in the log. So this is the same log we will see printed on the left side once all the tests complete. Just exiting back out to the main. Now we should see the bulk tests have kicked off. Those have completed. 183 passed, 0 failed. And we should now see the third-party setup provisioning run, as well as the third-party tests also executing following that. And now you can see the third-party tests have started. And those have completed. So on the left side, we should now see the logs printed in the terminal. And if we open up Slack, under the Mojaloop org, under announcements, we can actually see the tests that were just executed now printed in the announcements channel. So here we have the GP tests, the bulk tests, and the third-party tests. And in fact, we can even click on this to view a report. And here we can actually go into details. So you can click on the details themselves. This is obviously a summary of the 2,535 tests, 0 failed, etc., as well as how long it took to run them. It took around 2 minutes, roughly. And of course, we can click on the details themselves. And we can see the individual test cases that were executed. So for example, here's the P2P happy path for the received quote test, and we can see the individual requests that were sent. For example, we're also adding a participant to the ALS here, pay this fee with currency USD. We can see the response that was received, etc. And you can see here the quotes and the transfers. We can open up those and see the actual request bodies, as well as the responses, as the commit that was sent back, etc. And along with that, I also mentioned we also have included tests for the payee abort, etc. And you'll also see the tests for the settlements down below, the settlement management. Here you can see test creating settlement windows, store settlement, position balances, etc. And we have some test extent of transfers themselves, as well as create the settlements on the current open windows, prepare settlements, reserve settlements, commit, as well as finalize the settlements themselves, a couple of different use cases, etc., all the way down. And that is it. Thank you very much.
Thanks, Miguel. That was, I thought, was a really good presentation and demonstration of the tests that we have deployment. Thank you, Miguel. With that, let's move to the testing toolkit update. Let's see if I can play that video. Right, here we go.
Hello everyone,
Thanks.
This is Vijay Kumar. I am working for Modusbox as Solution Architect. I am here to give some updates on testing toolkit. So as you know, we released the Mojaloop training program on the testing toolkit in the previous PI. So feedback is welcome. Please go through the courses. And as Mojaloop version 13.10 is released, we combined the CGS collection, testing toolkit CGS collection, that means continuous gross settlement model with the multilateral model. And we have a single collection now in the testing toolkit golden path. So we are testing both settlement models as part of the Mojaloop testing out of the box. And then we parameterized some variables in the testing toolkit. That means, let's say for some deployments, they may use some custom resource versions. Let's say transfers is at 1.1 and codes will be 1.0. So in that case, we need to specify the expected versions for the TTK assertions while executing TTK test cases. So we can set those expected versions through the environment variables. So we changed the collections accordingly. And then with Mojaloop 13.10 version, third-party tests are included in the TTK third-party tests. And then we supported the teams who are using testing toolkit in many ways. And the significant feature is, new feature is supporting asynchronous APIs to be onboarded through UI. So we can just upload the Swagger file of our asynchronous API through the UI, and then we can map the request and callback through the UI itself now. So that's a new feature. And then we fixed minor issues with the UI and backend services. And there are two other new features. So first one is option to break test case in case of error. So for let's say for debugging purpose, if we get an error in a test case, we can choose an option to break the test case. We can choose an option to break the whole execution, or we can just skip the test case. So we included those options now in the UI. And there is a checkbox to disable requests. This is also for debugging. When we work with a test case, we may want to execute some only few requests, not all the requests in the test case. So in that case, we can disable those requests using this feature. I'm going to show some new features. So the first one is asynchronous API provisioning. This is the API management page. And here you can see these FSP APIs are asynchronous APIs. And you can see the new button here, edit mapping. So through this, we can specify the success and error callback for a particular request. Let's say this is post transfers. If we see this request, we can specify what is the success callback for this request. So that is put transfers, and then error callback, that is put transfer error. And also we can specify some values, some default values, which are used while simulating the responses and callbacks. So this is one feature, and then let's go to test runner. Here you can observe the new option here, break test case and error. So if we check this option, if there is one error in one assertion, then the whole test case will be skipped. And also we can choose this. If we select this, then the whole test case execution will be stopped. And the other feature is here. We can disable some requests now. So let's say if I execute this P2P test case, first we are provisioning the party in ALS and then simulator, and then executing the three-phase transfer. Let's say if I don't want these first two requests every time I test this. So I can disable that and run. So only these three requests will be executed. So this feature, these two features can be used in case of debugging. Yeah, I think that's it from me. Thank you.
Thanks, Vijay. Let me stop the share quickly. Give me a few moments. Just a moment. Now we have the infrastructure as code update by David. David, as you walk here, let me get the presentation ready. Okay, we have it. Share screen. Yeah, I think we're good. Thank you, David.
Thanks, Sam. Hello, everybody. I had a different slide deck prepared for giving the IAC updates, and then thanks to Simeon, where is Simeon? He's hiding, Algray. I decided I would switch it up and talk a bit about what he brought up yesterday, which is that there's interest on the part of the community about infrastructure in general, and there's confusion about how to run Mojaloop by different members of the community. So I wanted to talk a bit about that first, and then by the end of the presentation, get into some of the updates of what we've been working on. Okay, so after listening to the description of the interest that the foundation has in discussing infrastructure and coming up with a roadmap for this effort, I wanted to distinguish the different uses that we have for infrastructure within the participant community. So there's not just one size fits all. We have developers who want to quickly figure out what is Mojaloop about. They want to kick the tires. And for that user, we have the TTK with mocking capabilities, which is going to address that use case in a developer-friendly, lightweight fashion. We have a potential switch operator whose development team wants to look at a full dev environment with different capabilities of the switch. Perhaps a mini loop version would be the appropriate infrastructure to run. Then we have perhaps a hackathon effort. Would be a need for a sandbox. And there you have multiple users that need to access it, multiple participants. So then we start getting into more of, I'd say, the sweet spot of the IAC that we've been working on, which is really fit for purpose for sandboxes. But also we could see a vendor-specific solution there, whether it's Azure, GCP, or AWS that wants to put together a version of Mojaloop that's easy to spin up and maintain. This would also be appropriate. And then let's say there's a need for a countrywide switch initiative to run a POC. So there again, those two solutions, the IAC that we've been working on and the vendor-specific solutions, those would be appropriate. And then the last category that I would bring up is a production-grade switch. So what I'm saying here is that in order to provide the features for production, then you need to take what has been donated in the IAC effort and in any vendor-specific solution, and additional functionality is going to have to be added to that in order to provide those production-grade features. So basically, you're going to need to work with a vendor in order to provide you a solution depending on your requirements for fault tolerance, for security and throughput. So having delineated those different use cases, I want to talk about the sandbox infrastructure that we've been working on. So this effort started many years ago, and the initial Mojaloop development efforts were focused on AWS. So leveraging that as a starting point, we kept working with AWS, and that's been the focus of our effort. But we have been looking always to being cloud agnostic in our efforts. So we've taken the AWS as the starting point. We've also taken the original choice of components. WSO2 is the elephant in the room from my perspective. But we've gradually been replacing these with best of breed open source components. So what are the core principles for this development IAC effort, and how is that changed the original choice of components and cloud provider, and how is that going to direct us as we go forward? So for this sandbox, open source and standard-based components is the requirement. So obviously for vendor-specific solutions, that's not a consideration, but it is for us. And what we're striving to do in the current work effort is abstract away the cloud provider specific components so that the solution can become agnostic to that cloud provider, and will provide a pluggable way for different cloud providers to leverage the work that we've done and provide solutions for the community specific to that cloud provider. It's fit for purpose for sandbox environment, for fake money on fake rails. So that's the definition of what we're building for. And again, as I mentioned before, we're striving for a pluggable architecture so that we can plug in different cloud providers. We're also looking to support lower resource requirements, because the multi-cloud capability, pluggable capability, includes bare metal, because there will be situations in which a switch needs to run on bare metal. And running on bare metal sometimes means that you don't have the resource requirements to support a heavyweight Kubernetes cluster. So this is another core principle that we would like to strive for as well. From a CI/CD perspective and infrastructure as code execution perspective, we want to eliminate as many manual steps as we can, so that we have idempotent operations that allow us to reach the desired infrastructure state. And when I say infrastructure state, I mean the state of the actual infrastructure as well as the applications that are deployed and provisioned on top of that infrastructure. And then we need to provide an upgrade path for most components that would support that. So with these principles, we feel will provide the following benefits, and that is, for the open source project, it allows us to test the functionality on non-licensed components. So we have a completely open source stack that we can test all of the features of the solution. And anybody can use that as a starting point for their efforts without being encumbered by licensing issues. So now that I've described what we're focusing on, I've kind of said the infrastructure that we're focused on is the sandbox IAC. And I said that it needs to be open source only, and that we're striving for pluggable cloud providers. I want to talk about the components that we've focused on those open source components that provide the functionality that we need. The way that the IC is split, it is a kind of a layered cake. The base layer setting up the VMs and the base networking are obviously cloud provider specific. So again, we've only worked on the AWS version of this. But that first layer is where we try to keep all of the AWS specific code. The next layer would be the creation of the Kubernetes cluster itself. We use KubeSpray, which supports multiple cloud providers, but we would also strive to have a managed Kubernetes solution be pluggable in that layer as well. So after you've gotten past those two layers, everything on top is designed to be cloud specific, provider agnostic. So once you've decided I'm going to run on AWS, the first two layers provide that AWS specific infrastructure, and then the rest of the layers on top are providing components that live within that Kubernetes cluster that you built, but should have no actual dependencies on the cloud provider. So that would allow us, and that's the design, to then just build another first or second layer, depending on the solution, that's specific to Azure, to GCP, to bare metal, et cetera. So that we've isolated the changes required for supporting multiple clouds to those two lower layers, and potentially just the first layer if KubeSpray is the Kubernetes provisioner that's chosen. So the cloud agnostic components, I'm just listing them out. HashiCorp Vault for secrets management, certificate manager, and external DNS. These allow us to abstract away the DNS considerations and certificate generation. WSO2 ISKM and API manager. I put in parentheses there where we're planning to move ISKM to Keycloak and API manager to Ambassador / Ori stack. I would mention that Ori stack has already been implemented within the IC for the BizOps effort. Nginx ingress controller, HA proxy, not for reverse proxy, but only for forward proxying. And that is for callbacks to the DFSPs. Connection manager, and the BizOps framework that I mentioned before is leveraging Ori now. So I wanted to throw something quickly together to show again these two layers. Thank you. I put a box around these two layers of the infrastructure. So quickly, this is depicting how the CI works and how we create the bootstrap infrastructure for supporting multiple environments, sandbox environments. I've shown over on the top here, I'm not seeing the pointer here. So I'm showing here two environments, a dev and a QA environment. And we build out a tenancy with the bootstrap code, which provides the base DNS maintenance, the GitLab install, and some additional state management for all of the environments that you build. And the GitLab instance that's created is where the CI is run. So we have a CI runner and a GitLab repository where specific configurations for the environments and for the tenancy are stored and are used in order to, in the CI runner, to build out the VMs and the networking for which is cloud specific, and use KubeSpray to build out the Kubernetes clusters. And once these two items are done, the last part, which I have listed out here is cloud agnostic, is all those components that I listed in my previous slide. These get built using Helm charts, combination of open source publicly available as well as Mojaloop publicly available charts. And those are then provisioned in different, one Kubernetes cluster per environment. These all live in one VPC in different segregated subnets for the AWS implementation. So the purpose of this red box is to show this is the portion that needs to be changed per cloud provider. And as I referenced earlier, maybe just this section here needs to be changed if KubeSpray would be continued to be the Kubernetes provisioner of choice. Okay, so this is a view of the components that I listed out earlier and how they interact with each other. In particular, showing payment manager communicating with MCM, the HA proxy forward proxy that I mentioned that is used to make callbacks using mutual TLS, as well as whitelisting configuration that's happening. Vault is a central piece in communicating all of these secure details about the whitelists and the SSL certificate management. And also I'll point out that for the operator, hub operator, able to access Kube API, as well as Grafana for looking at metrics and using Loki for logs. So that's a brief description of the different components that make up the solution. And I tried to show how the cloud provider agnostic components differ from or are separated from the cloud provider specific components of the IAC. So now I'm going to talk about what I was originally going to talk about, which is the status update. And I've condensed this. So currently what we're doing is we're finalizing a release of the following functionality, which is supporting creation of stateful resources separate from the Mojaloop Helm releases, so that we can manage these databases and other stateful resources separate from the actual Helm install of the components that make use of them. So that would be Kafka, MySQL, MongoDB, and this is to support the Mojaloop central ledger account lookup, as well as connection manager and other components that make use of state. The second item is we have fully removed any manual certificate and DNS provisioning from the Terraform code. And now this is all making use of external DNS and Cert Manager. Cert Manager leverages both Let's Encrypt and Vault issuers. And we have moved off of EFK to use Loki for log searches, and the reasoning behind that is just the overall complexity of managing EFK, especially that's not warranted in a sandbox environment. So the next steps, as I mentioned, we want to make the cloud provider choice completely pluggable. We want to complete the move away from WSO2, and that would involve ISKM moving to Keycloak and API Manager moving to Ambassador. With the work that we've done in the move of the functionality of the ingress controller to manage the SSL offloading and IP whitelisting, we have done most of the work for setting us up for removing WSO2 API Manager. And with the ORI work that we've done with the BizOps, we've set ourselves up for a fairly seamless migration to using Keycloak instead of ISKM. We need also to convert the event streaming processor to make use of the Grafana stack. And we have some work as well to divorce ourselves from S3 Dynamo for Terraform and CI state management and move those to GitLab and use MinIO. So that's all I have from an update perspective. But happy to address any questions. Or Sam, do you want to continue with the next part of the slide and take questions at the end?
Interestingly, actually, Tom's update is next.
Oh.
Go ahead with your question, Tom, and then we'll go ahead with your.
There we go. Thanks, Dave. I really like the classification of the targets there. I thought that's great. Clarified, hopefully, something I was trying to say yesterday. But when you're talking about, say, HashiCorp Vault, and if you're talking about like an embedded engine, say EKS, do we have the flexibility to run HashiCorp Vault where they're using, say, their etcd secrets and stuff are using their Vault to get their encryption? So because that's out of our vision, isn't it, as a deployer? I'm just a bit confused. Maybe you can school me up afterwards, but I don't know how those things fit together with the managed providers. Does that make sense?
So HashiCorp Vault could be used for any kind of secret management, and you could just as well not use it for secret management that's already being taken care of by the platform. So there are some secret management functionality that's core to Mojaloop, then that is happening within HashiCorp Vault. And we can continue to leverage it for other purposes if it is warranted, but it doesn't have to be used. So if Azure wants to make use of its own vault for certificate management, it can go ahead. Or you can, if you wanted to leverage Istio here and certificate management was being handled out of band, it doesn't have to go through Vault. We use Vault for PKI engine management. And so that is a core open source functionality that we're doing within this implementation of IAC. But again, I think it's a case-by-case basis of where you want to manage your PKI and where you want to manage your key value secrets.
Okay, that makes sense. Thanks. And yep.
And sorry, just to add to that as well, there's a big difference between managing that at the internal security level and secrets level versus the JWS that we're sharing, and that kind of operational and more platform specific with the external providers. So for that reason, we need a robust certificate store and management layer.